All right, so normally when we do a problem like this, so I'm just going to rewrite this problem over here, the same thing, x squared plus 14x plus 49 equals 4. When we solve this with factoring, when we factor, we have to get it equal to 0. So when we factor this, we would have to subtract 4, and that gives us x squared plus 14x plus 45 equals 0. And then we can Sam factor that. And we can say what multiplies to 45 and adds to 14, which would be 9 and 5 both positive. And then when we set those factors equal to 0, because those two things multiply to equal 0, we got x equals negative 9, x equals negative 5. So that works. And honestly, like I said, we're going to learn some other strategies on how to solve quadratics, but as we kind of go through these other strategies, if you can factor something, factoring is going to be your easiest, okay? So we're going to do something else today called completing the square to help us solve. And we're going to start off with some easier ones, and then we'll see, like, okay, the main reason why you want completing the square is because if something's not factorable, you want a backup plan, okay? Remember, not everything's going to have something that multiplies to the last term and adds to the middle. So the directions here say, even though it's equal to 4, what do you notice about the first and last term? The first term's x squared, the third term's 49. What do you notice about those two numbers? What kind of numbers are they? Well, they're perfect squares. And this is actually a perfect square trinomial, that thing we talked about before, where I can make this into binomial squared. And if I have the square root of the first term, which would be x, the square root of the third term, which is 7, and then the sign of my middle term, that will be factored. Because remember, what that really is x plus 7 times x plus 7. And if you FOIL that, you're going to get the x squared plus 49 plus 14x plus 49. I did not get this equal to 0. It's still equal to 4. But notice, by me writing it that way, I got rid of that x, and then we can use the square root property that we talked about on Friday or Thursday. Okay, so I can undo this square now by square rooting it. And the square root of 4 is 2. So that's going to give me two answers. X plus 7 equals positive 2, and then x plus 7 equals negative 2. So we get x equals negative 5, which is what one of our answers was. And then when we subtract 7, x equals negative 9 as our other, which were the two answers we got by factoring. Again, me personally, this one's factorable, so I would think factoring is actually a little bit easier, but it's still an option for you. All right, so that's going to lead us into something called completing the square. And the reason why we did this first problem here, the number 1 there, is because when we're completing the square, what we're trying to do is we're trying to make this a perfect square trinomial, that left side. So there's two ways that you can do completing the square. It essentially does the same thing. I'm going to show you both ways, okay? So this first way, here are our steps. First thing we're going to do is get that constant over to the other side. So we just want the x squared and the x to be on the left side. So here we have x squared minus 18x plus 56 equals 0. So I want to move that constant to 56 to the other side. So I'm going to subtract 56. So that gives me x squared minus 18x equals negative 56. And we want a 1 in front of that x squared. So if there is an a, remember a is that number in front of the x squared. If there is an a, we're going to divide everything by a. Here our a is 1, so we don't have to worry about doing that. But that's what step 2 says, divide both sides by a. And now this is the completing the square part. So the completing the square part says you are taking half of the b term, you're squaring it, and then adding it to both sides. So what you're really doing is b divided by 2 squared. So our b term is negative 18. So I'm doing negative 18 divided by 2 squared. Negative 18 divided by 2 is negative 9. And negative 9 squared is 81. So what I'm doing is I'm adding 81 to the left side and the right side, because if it's an equation, it has to stay balanced. As long as I'm adding 81 to the left and to the right, that equation's staying balanced. Okay, so remember that right side already had a negative 56 on it. So I have on the right side negative 56 plus 81, and then on the left side I just added 81 to make it a trinomial. And so what we should have on the left side now, that's what step 4 says, what we should have on the left is a perfect square trinomial now. Because if you notice, 81 is a perfect square, x squared is a perfect square. So we can factor that just like we did above. I'm going to have a binomial square now. Square root of x squared is x. Square root of 81 is 9. And I have my middle term of a negative. And you can always double check to make sure it's a perfect square trinomial, because I can multiply the x and the 9 together, 9x, and then multiply that by 2, and you should get the middle term, which I do. And then the right side, 81 minus 56 is 25. And so we got rid of that x term that made us not undo. So now that we just have that parentheses squared with the x inside of that, we can undo that using our square root property. So now there's square root each side. Don't forget plus or minus. And then we would add 9. So again, that would be 5 plus 9, and then negative 5 plus 9. So we end up with getting 14, and we get 4. So the key is remembering to do that b over 2 squared. Okay, that's how you're getting that perfect square trinomial. All right, so for 4, again, following our steps, rewrite to the constants on the right. Our constant already is on the right. The negative 30 is on the right side. Now we're going to divide everything by the a. So notice how we actually do have an a. So I'm going to divide everything by 2, all my terms. Okay, so step 2 is done. We're doing our completing the square part now. So it's b divided by 2, so negative 8 divided by 2, squaring that. So that is negative 4 squared, which is positive 16. So that is what we are multiplying, or that's what we're adding to both sides. All right, so I'm going to have here x squared minus 8x plus 16 equals negative 15 plus 16. This is crazy. What's that even say? That's supposed to be plus 16. All right, so I have the perfect square trinomial on the left side now. 16 is a perfect square, so is x squared. So I'm making my two sets of parentheses. Quantity squared. Square root of x squared is x. Square root of 16 is 4. And it's a minus sign. On the right side, I now have 1. Again, the whole point of this is so that you just have that parentheses squared, nothing else. So we can now undo this by taking the square root of both sides. And so remember, that's going to give us two answers. X minus 4 equals 1. And x minus 4 equals negative 1. I'm pretty sure I'm writing, aren't I? Yeah. I think I gotta restart my computer, but all right. So I'd add 5 here. 1 plus 4 is I'd add 4. 1 plus 4 is 5, and then I'd add 4 again. 4 minus 1 is 3. So we get 3, 5. All right. So that's one way you can do it. If you like doing that way, the b over 2 squared, go ahead and do it. That's all good. The other way you can do it is with using algebra tiles. Algebra tiles is actually like the way this was created originally. So that is up to you on how you do this. But when you took probably pre-algebra or algebra 1, you may have seen algebra tiles. Algebra tiles, there's 3 different algebra tiles. There's an x squared tile. The reason it's called an x squared tile is because it's x units tall, x units wide. X times x gives us x squared. There's an x algebra tile. That's x units tall, 1 unit wide. X times 1 is x. And then there's a 1 algebra tile, which is 1 by 1. That's how you get an area of 1. So the whole goal of this, completing the square, is to create a square using the algebra tiles that are given to you. So the first two steps are the same. First thing you want to do is move that constant over to the other side, and then if there is an a value, you are dividing everything by the a. So if we look at the example here, okay, x squared plus 8x plus 8 equals 0. We're just moving that constant over. There is no a value, so I don't have to worry about doing that. So you're then, step 3 says you're drawing the x squared tile. Okay, notice there's a 1 in front of this x squared, so you have one of those x squared tiles. Remember, the x squared tile is x by x. For you to create a square, squares have equal side lengths. And squares have 2 dimensions. They have a base and a height. So if we have 8 of those skinny x tiles, and we have to split them between the base and the height, we are always going to take our x values and divide them by 2. And then you're going to draw that many x tiles on the other side. And then you label the base and height of your diagram now by adding or subtracting the number of x tiles that are connected on each side. Not right now. Alex is out. Yep. Okay, so since there are 8 of those tall, skinny x's, I'm going to divide that by 2, and I would essentially be drawing 4 of them this way, and I'd be drawing them 4 of them sideways also. And so the length of this whole side, this is, remember, this thing is x tall, but each one of these 1. So this is 1, 2, 3, 4. So this whole side length is x plus 4 units long. Same thing with this. This is x units wide. Each of these are 1, 1, 2, 3, 4. So this is x plus 4 also. And so the reason why it's called completing the square originally is because you need to figure out how many of the ones blocks you need in order to complete the square. And you do that by multiplying because you're finding an area. That's always going to be a negative amount because it's missing. Okay, we don't have that right now. Okay, so what is the area of this block down here? 16. It's 4 units wide, 4 units tall. It is 16, but since it's missing currently, it's always negative. So we're doing minus 16. All right, so then we're going to think of this whole thing as an area. And in the end, once we write it as an area, it should be in this parentheses squared form. So if we think of this whole thing as an area, it's x plus 4 units wide, x plus 4 units tall. What's x plus 4 times x plus 4? Another way of writing that. X plus 4 quantity squared, right? However, we're missing 16 from that area, so I'm going to put minus 16. And if we look on the right side, because all we're doing on the left side was rewriting it, okay? The right side still is going to be minus 8. But notice the goal is the same. We just have that parentheses squared. We got rid of the x here. And so we're now going to solve for x by undoing, which is the PEMDAS backwards. And if you have any irrational numbers or complex numbers, you would need to simplify them as well. So in this case, this wasn't factorable, so we're going to get an irrational number when we go and solve this, which is fine. So here we're going to add 16. Sixteen minus 8 is 8. All right. Now we can undo that square by square rooting. And so that would give us x plus 4 equals. Now, 8 is not a perfect square, but is there a perfect square that divides into 8? Which one? 4. So I'm just going to rewrite this as the square root of 4, square root of 2, which ends up being 2 root 2. So this becomes plus or minus 2 root 2. So that's what we mean by simplifying any complex or irrational numbers. All right, then to get the x by itself, we can subtract 4. So we would end up getting negative 4 plus or minus 2 root 2. Okay, that's fine as leaving it as an answer, or you could write it separately. You could do negative 4 minus 2 root 2, and then your other answer would be negative 4 plus 2 root 2. So if you like that way better, because maybe you're more visual, you can go ahead and use this way. If you can remember the b over 2 squared, use that way. Either way, for example 2, same idea to start. We're going to subtract 3. The thing that's a little tricky on this one is, remember, we always have to divide by 2 because we have two sides. 7 divided by 2 would be a decimal, 3.5, which is fine. So I would have my x squared tile. And then I'd have 3.5 on either side. So it's 3 full ones and then half of the width of another. And it really doesn't matter. You can just put minus 3.5. We don't have to draw it to scale. So how would we be getting that missing area? What would we do? Yeah, we're doing 3.5 times 3.5, or 3.5 squared. Which again, it's always negative, so that would be minus 12.25. Now again, if you're not able to use a calculator, I mean, you can use a calculator. They can do that. So you could use a calculator for 3.5 times 3.5 if you want. That's what 3.5 times 3.5 is. 12.25. Trust me. If it is 9.25. I'm sorry. Hold on. No, it's 12.25. After we do the subtraction, it's 9.25. Yeah. Yeah. All right, so we would be at x minus 3.5 quantity squared. We're missing the 12.25. And we are already at minus 3 before. I cannot read anything I just wrote, so I'm going to rewrite this again. As long as you could read it, what I wrote, it's not wrong. But all right, so it was x minus 3.5 squared minus the 12.25. And it's equal to the negative 3 that we had. That's what you should have. Nice and clear. We can see everything now. That's correct. Okay, now we can undo. So we undo the addition subtraction. So we're getting rid of this minus 12.25. So that would give us x minus 3.5 squared equals 9.25. And then we can square root both sides. Now, you don't have a calculator when you're doing these. There's no perfect square that divides into 9.25. So for what you're going to be doing is you will just be leaving it as plus or minus the square root of 9.25. Okay. Always look to see if a perfect square divides into it, but there's not going to be for one here. We add the 3 to it, 3.5. And so our final answer, we can leave it as 3.5 plus or minus square root of 9.25. And again, just remember that's two answers. 3.5 plus square root 9.25, 3.5 minus square root 9.25. All right, turn to the next page. You're going to try number 7 on your own. You can do either way you want. If you like the tiles, you do the tiles. If you like the b over 2 squared, you do it that way. No.